Alright, let's talk about the minimum depth of binary tree. So given a tree node, you want to find out the minimum depth from the root to the leaf, so the nearest leaf. So in this question, you are going to return 2 because this is level 1, level 2, level 3. This is a leaf, this is a leaf, this is a leaf. And the shortest path is going to be this guy. So the level is 2, you return 2. Alright, let's talk about the BFS pretty quickly. So the root can be what? 0, right? So which represent no. Then you want to return 0. Now you just add into the queue. And then if you cannot find it, just return -1. But you'll definitely find 1. Alright, so I would say queue.offer. I'm adding a root into the queue. I'm traversing, so when I traverse, I want to make sure I have a label. So I'm gonna call label starting from 1, right? And I need to know my current size of queue every single time. And I want to end my for loop based on my queue.size. So until queue is not empty, right? Until queue is empty, right? And then you want to increment your label every single iteration and also reinitialize your size equal to queue.size. And then you want to find out your current label for the size. So if you add 1, which is root, into the queue, you only traverse 1 time. If you add 2, which is going to be your second level, you just traverse 2 times. Just depend on your current level. And then I'm just tree node now equal to what? Queue.poll. Told this guy out, and then I want to check what does my node.left equal to no, and also node.right equal to no. If this is a leaf, if this is true, then this is a leaf, right? So you want to return a label, right? And then you can keep continue for the rest of the tree node. So it's going to be queue.offer, node.left. If node.right is not no, and then queue.offer, node.right. And then you increment your label based on your, the next iteration based on the for loop. Submit. Alright, so time and space, time. And for the space, it's going to be all of them. For worst case, you add every single node into the tree, a queue. And then for the time, you traverse every single one of them. So the worst case is going to be all of them for the time and space. And then for another solution, DFS, you can traversing the left and the right, and then find out what is your current minimum. And this is actually pretty hard to look at the solution. Alright, so if root equal to no, you return 0. So it will be hard to understand, be honest. And then I'm going to say in left equal to min left root.left. So no matter what, you want to traverse the left and right recursively based on the current level, right? And then if you are the leaf, you want to find out what is the minimum between the left and right. This is because you want to keep going up, right? Alright, this is what, imagine you are the leaf, and then you traverse the child, right? And you are no, you are nothing. So you come up to the current level, which is leaf. Then these are nothing, these are 0, left and right are 0. Minimum between 0 and 0 is 0. You plus 1 because this is your 1 level. And then you want to traverse. So root.left, if root.left equal to no and root.right does not equal to no, you want to think about this. So root dot left is null, and you have something on the right. You want to find out what is your level for the right, because this is not, I mean, on the left you have nothing to traverse, but on the right there must be a leaf, right? So it's going to be return 1 plus right. And if the root dot right equal to null and root dot left does not equal to null, you want to return 1 plus left. And here we go. So you have to twist your brain a little bit. Alright, time and space. This is space. This is time. You know, you're still going to traverse all of n, right? And the space is constant, right? So you can optimize this solution a little bit more. Alright, base case is going to be the same, and then this solution is going to be if root dot left does not equal to null and root dot right does not equal to null, which means you have children, so you want to return max dot min just between the what? Null dot left, comma, null dot right, and then plus 1. So in this case, you don't have anything on the left. Sorry, you have left and right, and then you want to find out the minimum between left and right. Alright, and then if you are not satisfied this condition, so you can be this case. So you can, so you can have left but you don't have right, or you can have right but not have left, or you can have nothing, which is considered a leaf. So in this case, you're still going to traverse because you want to traverse the left, right, and also traverse the right. You're still going to traverse, and then you want to find out the maximum value. You want to find out the maximum value for your current node, and then plus 1. So let's see. So return the max.max, and it's going to be this guy plus 1. So what does this mean? Oh, all right. Okay, so here's the idea. So if you are at this solution, and if you are at this corner, the diff, so the maximum is going to be what, left and right are 0, you plus 1 for yourself. And if you are at this solution, so 2, you have nothing on the left, 3, nothing on the left, 4, nothing on the left, 5, nothing on the left, 6. So so this is, I'm going to say that you have to twist your thought a little bit, and it might not be easy to understand, but think about this. This is not a leaf, right? This noise is not a leaf, so you want to keep going on the correct value, which is going to be what, the right side. So min dot right, so you will definitely return what, return 0 in this scenario, right? And you want to keep going right until here, right? And you will traverse again, and then you will get 0. Then you will come up a little bit, and then you say, all right, this is supposed to be so you are here, so you're back here, so it's plus 1, 0, 0, you're plus 1, so this is 1, this will be 2, this will be 3, this will be 4, this will be 5. All right, so just a little bit thought on this. And anyway, so if you understand, and then and know how to explain, you can leave a comment. But I would prefer BFS. BFS is pretty straightforward, and then you will be able to understand the logic. But DFS, you have to twist your thought a little bit. Alright, I'll see you next time. Bye.